Hello students, welcome to Deeksha Online Mathematics. Lecture 4, let us discuss conic section. So what do you mean by conic section? Now suppose if you take a line L1 or L1, this is L1, let us say. Let angle between them is theta. Then about L2, if you rotate L1 so that angle between L1 and L2 is always same. Then if you rotate like this, you will get two cones. This cone, if you divide or cut by a plane, suppose if you cut the cone exactly perpendicular to L2, let us say, by a plane, then the figure you can imagine on the cone is circle. Now if you cut the plane by putting with some angle, you will get ellipse. So if you cut the cone parallel to L2, you will get parabola. So if you cut the two cones, you will get hyperbola. So this is called how we get all figures by the section of a right circular cone by different planes. So this is the way how we get the shapes. So geometrically we understood how the different figures are formed. Now let us see another way of understanding conic section. Let us take a fixed point, that is called focus, and fixed straight line called directrix. If a point P moves in the plane such that SP by PM is a constant, and you know that this E is called eccentricity and the locus of P is called conic, and you know that if E equal to 1 it is parabola, if E less than 1 ellipse, if E is greater than 1 hyperbola. Now in general, now let us see different situations. Let us say this is S equal to 0, is a second degree non-homogeneous equation in x and y. Its discriminant is ABC plus 2FGH minus AF square minus BG square minus CH square. If this delta is equal to 0, we say that S equal to 0 represents degenerate conic. So what are the different situations in this? Under the restriction delta equal to 0, Suppose if that eccentricity greater than 1, h square greater than ab. In this situation, you will get a pair of straight lines, real and distinct. Suppose if e equal to 1, h square is ab, then you will get coincident lines. If e is less than 1, h square is less than ab. The lines will be imaginary with a real point of intersection. With a real point of intersection. So this point is treated in two ways. It can be treated as point circle also, because it's a point. In pair of straight lines, we call it as a pair of imaginary lines with a real point of intersection. Means that is a situation where the given second degree non-homogeneous equation represents only one point. Only one point. Now suppose if delta not equals to 0, it is a non-degenerative conic. In this, if e is greater than 1, h square greater than ab, you know that this will be hyperbola. E greater than 1, h square greater than ab, and a plus b equal to 0, it is a rectangular hyperbola. E equal to 1, h square equals to ab, it is parabola. E less than 1, h square less than ab, ellipse. So E tends to 0, A equal to B, H equal to 0, you know that this is circle. So for circle actually delta not equal to 0, but for point circle delta will be 0. So this is the different conditions. S equal to 0 represents what locus. Now let us see parabola. You know, if there is a fixed point and fixed straight line, the locus of the point which are equidistant from the fixed point and fixed line, that is SP by PM is equals to 1, eccentricity equals to 1. That locus is called parabola. So you know all the terms from which are related to conic, that focus, directrix, Z, and this line which is perpendicular to the directrix passing through focus, we call it as axis. Where the curve meets the axis is called vertex. Chord, perpendicular to axis, double ordinate, passing through focus chords, focal chords. If it is perpendicular to axis, focal chord, latus rectum. So different terminology you already know. So you know that y square equals to 4ax is the standard hyperbola. Let us discuss about that standard hyperbola. So for y square equals to 4ax, x-axis is the axis and y-axis is the tangent to vertex, and directrix So let us divide into three categories about y square equals to 4ax. That is, first let us discuss points. So what are the points related to y square equals to 4ax? I think you know, for this main is vertex which is at origin, and focus a comma 0. You know that a is always greater than 0, and z which is minus a comma 0, minus a comma 0, and extremities of latest rectum a comma plus or minus 2a. Then equations or lines. What are the equations of the lines which are involved in this parabola? Axis is there. Here it is y equal to 0. Tangent at vertex is x equal to 0. Directrix x equal to minus a. Latest rectum x equals to a. Then values. So say there are some numbers like length of latest rectum is 4a. SZ is 2a. AZ equals to a. AS also equals to a. So these are the information which I am dividing into three parts: points, equations, and values. So why I have divided like that? Okay, this is standard, and I think you know for x square equal to 4ay, you can write these points, equations, and values. Now, this is called shifted parabola. So for this, if you want to learn points, equations, values, a simple technique you can remember: for points, add alpha comma beta. For equations, subtract alpha comma beta. Values same. Means, suppose if I ask you what is the vertex for this. So what is the vertex for y square equals to 4ax? See, I will take y square equal to 4ax as the base parabola, and this y minus beta whole square equals to 4a into x minus alpha is a shifted. So vertex is shifted to alpha comma beta. So vertex, base vertex, you have to add alpha comma beta. For points, add. So for origin, if you add alpha comma beta, you will get alpha comma beta. Focus. So a comma 0 for the base, you have to add alpha comma beta, which you will get a plus alpha comma beta. Like that, if you want z minus a plus alpha comma beta, ends of latest rectum, a plus alpha comma plus or minus 2a plus beta. So to get points, you have to add alpha comma beta. Now suppose if you want to get equations, if you observe carefully, equation of the parabola itself is satisfying this property. For the base parabola, y square equal to 4ax, subtract alpha beta. So what do you mean by subtract? In the place of y, you will write y minus beta. In the place of x, you will write x minus alpha. So equation of axis will be, what is the equation of axis for the base? Y equal to 0. So here it will be, axis will be y minus beta equal to 0. What is the tangent at vertex? Y-axis, x equal to 0. Here, x minus alpha equal to 0. Directrix of this. So, what is the directrix there? X equal to minus a. So, x minus alpha equal to minus a. Equations of lattice rectum. X minus alpha equals to, actually x equals to a, no? So, x minus alpha equal to a. So, this will be equations of lattice rectum. Equation of lattice rectum. So, simple, you remember this, and I told you values will be same. Length of lattice rectum 4 is values won't change. So to get the points, add alpha beta. To get the equation, subtract alpha comma beta. Then for parabola, parametric equations are very important. Parametric equations are very important. So let us discuss what are the parametric equations for the standard parabola y square equal to 4ax. So I can take x equals to at square, y equal to 2at are the parametric equations for the standard parabola. So this at square comma 2at, where this t belongs to real numbers, we call that point as simply t. The locus of this point will be the parabola y square equals to 4ax. So with this parameter t, we can understand parabola very easily. Suppose if I ask you on a parabola, if t1, t2 are 2 points, what is the equation of chord? So equation of chord will be what? Y into t1 plus t2 is equal to 2x plus 2a t1 t2. So you can use 2-point formula. Let t1 is a point on the parabola. What will be the point? at1 square comma 2at1. t2 be a point on the parabola. at2 square comma 2at2. Use 2-point formula and simplify. You will get y into t1 plus t2 is equal to 2x plus 2at1 t2. So y square equal to 4x. If t1 is a point, so a of t1, b of t2, then the chord joining ab. So this is the equation. Now if that chord passes through focus, what is the focus? A comma 0. So if you substitute, you will get a condition t1 t2 equal to minus 1. So what are t1 t2? t1 t2 are the parameter values for the point at1 square comma 2at1. t1 is a parameter. at2 square comma 2at2, t2 is the parameter. So the product of those parameters will be equals to minus 1 if it is a focal chord. If it is a focal chord. Now suppose if I substitute t1 equal to t2 equal to t, then what you will get? You will get a tangent. You will get a tangent. So what is the equation of tangent? So just recollect what is the chord equation? Y into t1 plus t2 equals to 2x plus 2a t1 t2. So let us substitute this. So what will you get? Ty or t1 plus t2 2ty is 2x, 2a t1 t2 will be t square. Then if you cancel 2 on both sides, x minus yt plus at square equal to 0. So this is the equation of tangent at t. So you can develop this equation by s1 equal to 0. You know the notations, no? Using that notation concept also, using s1 equal to 0 formula also you can get. Or you can use calculus method, differentiate, get the slope at t, point slope form. So what is the slope of tangent at t is how much? 1 by t. So simply the reciprocal of parameter will give you slope. Then what will be the slope of normal at that point? Suppose this is a parabola. At some point this is the tangent. At this point if I draw normal, this is t, let us say. The slope of normal will be minus t. Then equation of normal, if you write y minus y1 2a t equal to minus t into x minus at square. So this is equation of normal. You know that if this normal passes through some point x1 y1, if I fix, I told you this concepts in circles also. This is the equation. T is the parameter, means t represents any point on the parabola. So this contain equation of all infinite normals in it. Now I am saying that normal passes through x1 y1. So if that normal passes through x1 y1, then if I substitute in the place of x1 y1, I'll get a cubic equation in t. So what is the cubic equation in t? We will get at cube plus 2a minus x1 into t plus y1 equal to 0. This cubic equation is telling you that there can be maximum 3 normals which can pass through x1 y1. So using theory of equations, if the roots are t1 t2 t3, you know that t1 plus t2 plus t3 is 0 here. t1 t2 plus t2 t3 plus t3 t1 equals to 2a minus x1 by a. t1 t2 t3 will be y1 by a. So we can say that maximum number of normals which we can draw or which will pass through a given point will be 3 for parabola. Now let us see some properties with this, using this parametrics. Means a lot of things we can easily prove, we can easily develop using parametric forms. Suppose I'll tell you one thing. Just now we proved that for a parabola, if t1 and t2 are the parameters of a focal chord, let us see. This is focus. Now suppose if I draw tangent at t1, we proved that 1 by t1 is the slope of tangent at t1. Then what is the slope of tangent at t2? 1 by t2. What is the product of slopes? 1 by t1 t2. Since it is a focal chord, t1 t2 is minus 1, so product of slopes you got minus 1, so angle is 90 degrees. Angle is 90 degrees. Then if you solve the equation of tangent at t1 and at t2, you will get the point of intersection of tangents also. So the point of intersection of tangents will be a t1 t2 comma into t1 plus t2. You can solve it. But t1 t2 again minus 1, no? So its x coordinate will be minus a. So this point of intersection is lying on directrix. What do you understood this here? So what we understood here is directrix is the locus of point of intersection of perpendicular tangents. See, all these things we can easily understand by using parametric forms. Now suppose what is the slope of tangent at t2? 1 by t2. Then what will be the slope of normal at t2? What is the slope of normal at t2? minus t2. But you know that 1 by t1 is equal to minus t2 because t1 t2 equal to minus 1 means normal at one extremity of the focal chord, tangent at other extremity of the focal chord are parallel to each other. So this also we can prove very easily. Now you have some more properties like if the normal at t1 meets the parabola, normal at t meets the parabola at a parameter. What is that parameter? Minus t minus 2 by t. Similarly, suppose you have 2 points t1, t2 on parabola. Normal at t1 and normal at t2, they are meeting on the parabola at t3, let us see. Then you have some relations like t1 t2 will be 2 and t1 plus t2 plus t3 equal to 0. Let us discuss. If you take a parabola, at t you are drawing a normal. So I can call this as a normal chord. If the normal chord subtends 90 degrees at the vertex, then t square will be 2. If normal chord subtends at focus 90 degrees, t square will be equal to 4. So all these things we can, by using parametric forms, we can use or we can develop very easily. Suppose at t you are drawing a focal chord. This is focal chord. The length of that focal chord will be a into t plus 1 by t whole square. So this is length of focal chord. Suppose at t you are drawing a normal, which is a chord, normal chord. So this is tangent, this is normal. So normal chord. So the length of normal chord at t will be 4a into 1 plus t square whole to the power of 3 by 2 divided by t square. So this is the length of normal chord at t. And you know that suppose PQ is a focal chord passes through S, then this 1 by SP plus 1 by SQ is 2 by L, where L is nothing but semi-lattice rectum, which is 2A. Semi-lattice rectum. See, you can prove this by any way, but if you use parametric, these results will be very easily you will get. Suppose You take three points on the parabola. Draw the tangents. So tangents at T1, T2, T3. You know tangents, formulas, how to write tangents. Then those three tangents so if we extend this, the tangents will form a triangle. The orthocenter of that, if you find, lies on directrix. See, actually it's a very big problem. But if you use parametric formulas, very easily you can develop the result. X coordinate you can prove -8 is enough. So orthocenter of the triangle formed by the tangents, three tangents to a parabola, lies on the directrix. So similarly, you can prove a lot of properties using parametric. Let us discuss one more point. Suppose you have a parabola. This is directrix. Let P be a point on the parabola. S is the focus. Let us draw from P some M perpendicular to directrix. This is SP. Then if you extend this PM, you know that this is one angle between line PM and line PS, and this is another angle. Tangent at P and normal at P will be the angular bisectors of the angle between SPM. If you observe carefully, SPM angle, tangent is the angular bisector, we can say internal angular bisector, and normal is the external angular bisector. So by using this property, that reflection on a parabolic mirror, reflection of a line problems we can do using this property. Now let us discuss algebra. So what is algebra? I told you in circles also, we can use algebra to understand the concepts very easily. Let us take the standard parabola y square equals to 4ax. And y equal to mx plus c is a line in that plane of parabola. Then if I substitute y equal to mx plus c, means one locus I am inputting into another locus, then what I will get, mx plus c whole square equal to 4ax. So m square x square plus 2mcx minus 4ax plus c square equal to 0. So you'll get m square x square plus 2mc minus 4a into x plus c square equal to 0. So you got a quadratic in x. What it says you? The line y equal to mx plus c can cut maximum in 2 points the parabola y square equal to 4ax. To get it, you know that discriminant of this quadratic equation will help you. If discriminant is greater than 0, the line meets the parabola in two real and distinct points. If discriminant equal to 0, the line meets the parabola in two coincident points. See the statement. The line meets the parabola in two coincident points. This is the situation of tangency. And this is a situation of secant line. When delta less than 0, the line does not meet the parabola. The line does not meet the parabola. Then if you take delta equal to 0, you will get the condition C equal to A by M. So this is a condition for tangents. So y equal to mx plus a by m. So when y equal to mx plus c, there were two parameters m and c. If that line is a tangent to the parabola y square equal to 4ax, then y equals to mx plus a by m is the equation of tangent with m as the parameter. So for y square equal to 4ax parabola, you will have infinitely many tangents. All those equations are stored in this y equal to mx plus a by m. Suppose if I say that this tangent is passing through a point x1, y1, then what you will get? Y1 equal to mx1 plus a by m. If you take LCM and cross multiply, m square x1 minus my1 plus a equal to 0. So y1 equal to mx1 plus a by m. Take LCM, m square x1 minus my1 plus a equal to 0. So when I substituted a point x1, y1, I got this. So this is becoming a quadratic in m. See, in this step, m has infinite values. When it passes through x1, y1, you got a quadratic in m. You got a quadratic in m. So quadratic in m says you that in these infinitely many tangents, maximum number of tangents which can pass through a point x1, y1 are 2. Whether those two are real or distinct, real and distinct or real and same does not exist, means tangents are imaginary. All will depend on delta. So what is delta? Y1 square minus 4a x1, which is nothing but S11, which tells you the position of the point. So if S11 is greater than 0, means discriminant greater than 0. So what is the meaning of that? There exists two m's. So if delta greater than 0 means if the point is outside the parabola, there are two tangents to the parabola. Let m1, m2 are their slopes. Then from the quadratic equation, what is m1 plus m2? y1 by x1. What is m1, m2? a by x1. Suppose if I say to the parabola, if I draw two tangents from a point P which are perpendicular to each other, so m1, m2 must be equal to minus 1. So what is the locus you are getting? X equal to minus a, which is the directrix. So from directrix, from any point, if you draw tangents to a parabola, they will be perpendicular to each other. Now all the things which I told in circles are valid here also. If I substitute y equal to mx plus c in the line or given line in the parabola equation, if you eliminate y, you will get a quadratic in x whose roots will be x1 comma x2, whose roots will be x1 comma x2. So you can find difference between the roots by substituting x1 y1 x1 value and x2 values in the line equation. You will get corresponding y coordinates. So you can find the length of the chord intercepted by the parabola. Now, not only that, you can find angle between tangents as tan theta equal to m1 minus m2 by 1 plus m1 m2, and by using the separate equations of tangents you can find pair of tangents. So all the things which we have developed in circles by using algebra we can use in parabola also. Let us discuss chord of contact, chord with midpoint polar. Suppose if you take a parabola for a point P x1 y1, outside you can draw two tangents. Let PA and PB are tangents. Then the chord AB is called chord of contact. Now if there is a chord for the parabola with midpoint x1 y1, the equation of that chord will be S1 equal to S11. What is the equation of chord of contact? S1 equal to 0. Then similarly you know polar also. What is the polar definition? Point of intersection of tangents drawn at the extremities of the chords which pass through a given fixed point P. So what is the equation of polar? Equation of polar is also S1 equal to 0. So tangent equation at a point x1 y1 is also S1 equal to 0. Now if I ask you some things like what is the polar of a point on the directrix? It should be focal chord. So mix up the concepts, parametric, what you learned, you mix up, you will get very easily. The pole of the line, pole of the focal chord lies on directrix. Conjugate points, conjugate lines, everything which we discuss in circles are also we can discuss here. By your own you can develop the formula. Diameter. As you know, the definition of diameter is locus of the midpoints of parallel chords. Suppose if I take one chord like this, this is a chord. Now draw the parallel chords for the given chord. So let the slope of this is m. So let us take the midpoints of these parallel chords. So this is locus of the midpoints of the parallel chords. This is called diameter. So diameter is the locus of midpoints of parallel chords. If you want to get the equation of a diameter, let x1 y1 be the midpoint of one chord. Then equation will be s1 equal to s11. So y square is y by 1. So because s is y square minus 4ax, s is, so s1 is y by 1 minus 2a into x plus x1. s11 will be y1 square minus 4ax1. So what is the slope here? Minus x coefficient is 2a by y1. Minus x coefficient is minus 2a by y1, which should be equal to m, because slope of the parallel chords must be equal to m, we assumed. Now y1 equal to some constant. So what is the locus? Y equals some constant, which is always parallel to axis of the parabola. So all the diameters in the parabola are parallel to the axis. So center does not exist for the parabola. Let us see another definition of parabola. So if you observe the standard parabola y square equal to 4ax, suppose if you take axis of the parabola whose equation is y is equal to 0, tangent at vertex is x equal to 0, let P be a point x comma y on the parabola, then the perpendicular distance to axis will be y coordinate of the point, perpendicular distance to tangent at vertex will be x coordinate of the point. So here y square equal to latest rectum into x. By observing this, let us generalize this as ax plus by plus c equal to 0 is axis, and tangent at vertex is bx minus ay plus d equal to 0. Then equation of parabola I can write ax plus by plus c divided by root over a square plus b square whole square, perpendicular distance from any point to axis is latest rectum into bx minus ay plus d by under root of b square plus a square. So this is the equation of the parabola, or understanding parabola in another way using axis and tangent at vertex. Okay, now let us see ellipse. So the definition of ellipse, you know, if SP by PM, that is eccentricity E is less than 1, so if S is a fixed point, directrix SP by PM will be less than 1. So according to the symmetricity, you know that you will be having two foci, two vertices, two directrices for the ellipse. So SP by PM, which is E, which is less than 1. So this is the definition of ellipse. So let us see x square by a square plus y square by b square equals to 1, a greater than b. So this is called standard ellipse. Major axis will be x axis, minor axis will be y axis. Here also I want to divide into three categories. The point's center will be origin, vertices will be plus or minus a comma 0, and b and b dash on minor axis are 0 comma plus or minus b, foci plus or minus ae comma 0, z and z dash plus or minus a by e comma 0, latest rectum ends so you will be having two latest rectum, so plus or minus ae comma plus or minus b square by a. So which combinations? Because it is a horizontal ellipse, first fourth quadrants 1, second third quadrants 1. So those will be the sets of lattice rectum you have to take here. Then, so if you see the ellipse, so vertices, these are the vertices, foci z and z dash, then this is b and b dash, now what are the equations? Equation of major axis, x-axis, no, y equal to 0. Equation of minor axis, x equals to 0. Then equations of lattice rectum, x equal to plus or minus a. Equations of directrices, x equal to plus or minus a by e. So these are the equations. So what are the tangents at vertices? Tangents at vertices will be x equal to plus or minus a. So if you see the figure, this is axis, major axis, minor axis, tangents at vertices, directrices. You can find the equations of lattice rectums also. X equals to, already I have written, x equal to plus or minus ae is the equation of lattice rectums. X equal to plus or minus a by e is the equations of directrices. So this is about equations. Now values. So what are the values? To get the values, you should learn first this relation. B square will be a square into 1 minus e square, from which e square will be a square minus b square by a square. So this is the first value. Length of major axis will be 2a. Length of minor axis will be 2b. So this will be length of major axis, length of minor axis. So length of lattice rectum 2b square by a, and sum of the focal distances sp and s dash p is always equals to length of major axis, which is 2a. Distance between foci is 2ae. Distance between vertices nothing but major axis 2a. Distance between z and z dash 2a by e. See, if you observe the figure, these are all you can develop. So when you understand these things, for the other ellipse, vertical ellipse, also you can find. Okay, before that vertical ellipse, let us see shifted horizontal ellipse. As I said in parabola, here also it is valid. Means now this alpha comma beta is the center. For points, for the base ellipse, add alpha comma beta. For equations, subtract alpha comma beta. And values will remain same. No effect. Vertical, you know that axis will become y-axis, that is major axis, and minor axis will become x-axis. Now according to that, you have to change the formula. Here I think already you know formula well, but I am telling you how to get the shifted ones very easily. For points, adding alpha comma beta. For equations, subtracting alpha comma beta. Now let us introduce algebra to develop some properties. You know x square by a square plus y square by b square equal to 1 is the ellipse, and y equal to mx plus c is the straight line. If they are in the same plane, let us substitute y equal to mx plus c. So you are inserting one locus into another locus. So you will get x square by a square mx plus c whole square by b square equal to 1. So if you simplify this, you will get a quadratic in x. So I'm not simplifying, just I want to tell you what will happen, because in circles parabola I have already done it. So simplification will be some lengthy, but what will happen? So what will happen? You will get a quadratic equation x whose roots will be x coordinates of the points of intersection of this line and ellipse. But what is the guarantee that this line meets the ellipse? Yes, that's why that quadratic in x discriminant will tell you what will happen. So if delta greater than 0, line meets the ellipse into real and distinct points. If delta less than 0, line does not meet the ellipse. Delta equal to 0 is a condition of tangency, because line meets the ellipse in two coincident points. So what is the condition for tangency? C square equals to a square m square plus b square. Then what will be the c value? Plus or minus root over a square m square plus b square. So can I say y equal to mx plus or minus c root a square m square plus b square will be the infinite tangents for the ellipse. If this y equals to mx plus or minus and root of a square m square plus b square passes through a point x1 y1, so you can't have infinite m's now, because we are saying that it's passing through x1 y1. So substituting this point, y1 minus mx1 whole square equal to a square m square plus b square. So if you simplify, it will be x1 square minus a square into m square minus 2x1 y1 m plus y1 square minus b square equal to 0. So what do you got? Quadratic in m. So this says that the maximum number of tangents out of those infinite tangents can pass through the given point x1 y1 or 2. That also depends on the discriminant of this quadratic equation. If it is greater than 0, it will have two real and distinct values for m. As you know that this delta depends on S11. S11 according to the location of the point x1 y1. So if delta greater than 0 means S11 greater than the point lies outside, then two tangents will pass through x1 y1. If point lies on the ellipse, S11 will be 0, only one tangent. If point lies inside, S11 will be less than 0, no real tangents, but point of intersection is real. So imaginary tangents with real point of intersection is x1 y1, if the point is inside. So suppose if I take delta greater than 0, that is point lies outside. So ellipse, point lies outside. So you can draw two tangents. These two tangents, let us say the slopes are m1 and m2. So what is m1 plus m2 from the quadratic equation? It is 2x1 y1 by x1 square minus a square. What is m1 m2? m1 m2 is y1 square minus b square by x1 square minus a square. If m1, suppose tangents are perpendicular to each other, This m1 m2 must be equal to minus 1 then what you will get? Locus you will get x square plus y square equals to a square plus b square. Means you are getting a circle with center x1 y1 and radius under root of a square plus b square. That circle is called director circle. The circle is called director circle. So if you observe this word director, for even circles chapter also same director circle. Where circle and ellipse are closed figures, the locus of the point of intersection of perpendicular tangents is becoming a closed figure. For parabola, since it is an open figure, directrix. So director circle is becoming directrix there. So that is about director circle. So similarly now you can discuss angle between tangents. So suppose if you have px1 y1, you can get the individual slopes and get the individual tangents. You can get the angle between tangents. And to get the pair of straight lines, direct procedure is also there. S1 square equals to S11 into S. Or you can get the individual slopes and get the equations of individual tangents. Multiply them to get the pair of tangents. Now auxiliary circle. So what is auxiliary circle? It is a locus of feet of perpendiculars from foci of the ellipse to any tangent to the ellipse. So if you have ellipse on the major axis as diameter, if you construct a circle concentric with the ellipse, this circle is called auxiliary circle. So it is a locus of locus of feet of perpendiculars. Locus of feet of perpendiculars from foci to any tangent to the ellipse. That is auxiliary circle. Let us see parametrics form. For that, let us understand what is eccentric angle. Suppose if you have an ellipse and this is auxiliary circle, let P be a point on the ellipse, C be the center of the ellipse and auxiliary circle as well. From P, if you draw a perpendicular Pn to the major axis and extend NP to cut the auxiliary circle at P dash. Then join this CP dash. This angle theta is called eccentric angle of both P dash and P. Then P dash will be a cos theta comma a sin theta, because auxiliary circle x square plus y square equals to a square. Then P will be a cos theta comma some k. If we substitute in the equation of ellipse, you will get k equal to plus r minus b sin theta. We take plus, because minus will be its opposite quadrant. So x equal to a cos theta, y equal to b sin theta will be the parametric equations, and this will be represented by the point theta. So theta a cos theta comma b sin theta. So if I say alpha is a point on the ellipse, you should understand a cos alpha comma b sin alpha. Let us see diameter. Same. Suppose an ellipse is there, you take any one chord, take its parallel chords, so locus of the midpoints of parallel chords is called diameter. All the diameters are concurrent in this ellipse, and the point of concurrency is called center of the ellipse. That is about diameter. Conjugate diameters. Two diameters are said to be conjugate when each bisects all chords parallel to the other. When each diameter bisects all chords parallel to the other, then we call them as conjugate diameters. Suppose y equals to m1x, y equal to m2x are two diameters of the standard ellipse. M1 M2 must be equal to b square by a square. Very clearly, b square by a square means the conjugate diameters angle between them cannot be 90 degrees. But remember that the ends of conjugate diameters, suppose you have, these are the conjugate diameters, some PQ and AB, then if it is theta, this is phi, the eccentric angles differ by pi by 2. The eccentric angles of conjugate diameter differ by pi by 2. So ellipse, that other definition, everybody know, the SP plus S dash P equal to 2A. So locus of the point, suppose there are two fixed points, the locus of the point whose sum of the distance from two fixed points is always greater than the distance between them, then locus will be ellipse. So this is another definition, but one more important understanding is there. If you see x square by a square plus y square by b square equals to 1, axis, two axes, major and minor axis. So here this is y equal to 0, this is x equal to 0. So this x, suppose if you take any point, perpendicular distance to major axis will be denoted by y coordinate, perpendicular distance to minor axis will be x coordinate. So when it is this, for this figure, y is major axis, x is y equal to 0 is major axis, x equal to 0 is minor axis. So please observe this a, when a is greater than b, minor axis perpendicular distance from P to minor axis by semi-major axis length whole square plus perpendicular distance from P to major axis whole square divided by semi-minor axis length whole square is equals to 1. So if you observe that ellipse in that way, we can write ellipse equation in another way, that is L1x plus M1y plus N1 by under root of L1 square plus M1 square whole square by a square plus M1x minus L1y plus N2 by under root of L1 square plus M1 square whole square by b square equal to 1, where this L1x plus M1y plus N1 equal to 0, M1x minus L1y plus N2 equal to 0 will be major and minor axis. So which is major, which is minor, this cross technique you remember. Suppose if I say A is greater than B, so A should be major. So above a square you should have minor axis, perpendicular distance to minor axis, and obviously the other one will be major axis. Suppose if A less than B, so which is greater, B. So above B and which is greater, above that you should have length of perpendicular from P to minor axis. Suppose if I say you, if A is greater than B, now you tell me which will be the major axis. When A is greater than B, major axis will be M1x minus L1y plus N2 equal to 0. Minor axis will be L1x plus M1y plus N1 equal to 0. If A less than B, which will be the major axis? L1x plus M1y plus N1 equal to 0 is the major axis. The other one will be the minor axis. So after learning ellipse, hyperbola learning will be very easy. So when eccentricity E is greater than 1, the conic which is formed will be hyperbola. Here the terminology will change somewhat, that instead of major and minor, here you will have transverse and conjugate axis. And very important thing here, if the point lies inside, S11 will be greater than 0. If the point lies on S11 will be 0. If the point lies outside S11 will be less than 0. That is about hyperbola. So let us discuss about hyperbola with the help of ellipse formulas fastly. So for hyperbola also you will have same formulae. Center will be origin, vertices will be plus or minus a comma 0, foci will be plus or minus e comma 0. The only thing is e is greater than. So all the formula will be same. Equations here, the terminology I told you, equation of transverse axis will be transverse axis will be y equal to 0, conjugate axis is x equal to 0. So equation of lattice sectum, everything will be same. Then values, length of lattice sectum, length of transverse axis, length of conjugate axis, all those things you have to learn. From ellipse you can learn that. And this will be a hyperbola whose transverse axis will be y-axis and conjugate axis will be x-axis. So x square by a square minus y square by b square equal to minus 1. As in ellipse a greater than b, a less than b won't be there here. For given hyperbola or its conjugate, a can be less than b or a greater than b. Equals to b, it is called rectangular hyperbola. So this also no need to discuss here, because you know that for points you have to add alpha comma beta. For equations you have to subtract alpha comma beta. For values no change. Already I told what is conjugate hyperbola. Then rectangular hyperbola, I told you length of transverse axis will be equal to length of conjugate axis. So a equal to b. See this a equal to b, I am telling in x square by a square minus y square by b square equal to 1. In that I am telling, or minus 1, no problem. So in that I am telling that the values a equal to b, length of transverse axis, length of conjugate axis. So generally we can say x square minus y square equals some k is rectangular hyperbola. Some rectangular hyperbolas will be in the form of xy equal to c square also. This is another rectangular hyperbola. Here also algebra we can introduce. Then you will get y equal to mx plus r minus under root of a square m square minus b square. You will get as the infinite tangents, and if it passes through x1 y1 director circle equation, you will get x square plus y square equal to a square minus b square. And sum of the slopes, product of the slopes, that product of the slopes, if you equate it to minus 1, you will get this director circle. Angle between tangents, pair of tangents, everything you can do. Now if you observe, the condition for tangents is c square equals to a square m square minus b square. Suppose if c equal to 0, means for the hyperbola there is a line which is passing through origin, what happens? Then m square will be equal to b square by a square. Then m will be plus or minus root b by. Means there exist m2 values for which the line which passes through origin will be a tangent to the hyperbola which never meets the hyperbola. These pair of lines are called asymptotes. These pair of lines are called asymptotes. So asymptotes are the pair of tangents passing through the center of the hyperbola. And some properties, asymptotes and hyperbola, the equations differ in constant. And remember, asymptotes is a pair of straight line. Suppose if you are given hyperbola equation, corresponding asymptotes if you want to find, change the constant and apply delta equals to 0 condition, you will get asymptotes equation. Angle between asymptotes is 2 tan inverse b by a, or you can use 2 secant inverse eccentricity e. If it is a rectangular hyperbola, you know that a equal to b, or for rectangular hyperbola e will be how much? Root 2. So angle between asymptotes will be 90 degrees for rectangular hyperbola. Suppose if h is the equation of hyperbola, h equal to 0, and c equal to 0 is the equation of its conjugate hyperbola, and a equal to 0 is the asymptotes equation, always remember that h plus c will be equal to 2a. H plus c will be equals to 2a. Here also auxiliary circle, same eccentric angle, and auxiliary circle equation will be x square plus y square equal to a square. From that you can generate the parameter. So the parametric forms here will be x equals to a secant theta, y equal to b tan theta, and that point a secant theta comma b tan theta will represent as theta. Here also you can learn chord, tangent, everything. So let us learn about a special hyperbola which is rectangular, xy equals to c square. For this xy equal to c square, the parabola will be like this. So asymptotes are coordinate axis, and its transverse axis will be y equals to x, and conjugate axis will be y equals to minus x. And its length of lattice rectum, 2 root 2c. And what will be the equation of director circle? X square plus y square equal to 0, that is a point circle. And what is the parametric form on this? Can I take ct comma c by t and name it as t? So this is very easy. If you take ct comma c by t as the parametric form on this, so you can write equation of tangent, equation of normal at t. So by using this parametric, you can solve some problems on this rectangular hyperbola. Here also conjugate diameters same as ellipse. If two diameters are there, y equal to m1x, y equal to m2x, then m1 m2 equal to b square by a square is the condition for conjugate diameters. If two diameters are conjugate diameters for a given hyperbola, they will be conjugate to the conjugate hyperbola of the given hyperbola. So remember that if a conjugate diameter meets the hyperbola in real points, then the other conjugate diameter meets in imaginary points. So there are two conjugate diameters, no? If one meets the hyperbola in real points, its conjugate diameter meets the hyperbola in imaginary points. That is very, very important point in this conjugate diameters in hyperbola. The other definition of hyperbola. Let S and S dash are two fixed points, then SP, S dash P, difference must be a constant, and that constant must be less than SS dash. Then only the locus will be hyperbola. Similarly, just like in ellipse, L1x plus M1y plus N1 by under root of L1 square plus M1 square whole square by A square minus M1x minus L1y plus N2 by under root of M1 square plus L1 square whole square by B square equal to 1 is also hyperbola. Suppose if you take, the logic is like this: x square by a square minus y square by b square equals to 1. Just like an ellipse, same thing. Suppose if it is semi-transverse axis length, then this y equal to 0 must be transverse axis. This is semi-conjugate, x equal to 0, conjugate axis equation. Similarly, if A is semi-transverse, then its opposite, this will be transverse equation, transverse axis equation. That's all. Thank you.